Hey, it's Mr. Allred here. We've talked about domain, we've talked about implied domain, and here we are, we're going to try and find the domain given some algebraic functions. So the first one, A here, f of x equals 3 times the square root of 2x plus 9, and then minus 4 at the end. In this particular one, we have a square root, so we're going to take what's under that square root, and we're going to set it to be greater than or equal to 0. So 2x plus 9 to be greater than or equal to 0, because we can't have a negative under the square root because that'll leave to the imaginary system. And if we get x by itself, we'll have x greater than or equal to negative 9 halves, and that's the domain. So those are the only numbers that work in that particular one. The second one, B, g of x equals the fraction 5x minus 4 on top and x plus 3 on the bottom. This one has a denominator of x plus 3. So denominators mean we're going to take that and set it x plus 3 not equal to 0 because we can't divide by 0. So we'll get that by itself, so x cannot be negative 3. That's our domain. So we can put any real number in G except negative 3. C, h of x equals the fraction on top 7x squared, on bottom x squared plus 9x plus 18. And here we have a denominator. Remember, our denominators can't be 0. So we'll set this thing up. X squared plus 9x plus 18 does not equal 0. That is a quadratic that actually factors into x plus 6 times x plus 9, which we'll say is not equal to 0. So we'll set each one of those not equal to 0, and my domain will be x does not equal negative 6, and x does not equal negative 3. So I can plug any real number into that h function except negative 6 and negative 3. Those will make it undefined and cause me to divide by 0. D is the function f of x equals 9x cubed plus 5x plus 8. In this particular one, there's no denominator, there's no root. This domain is all real numbers. There's no real numbers that I can plug in that will cause me any problems. E, g of x equals 4 minus the square root of x plus 12. I have a root, under it is x plus 12. So remember, we're going to say x plus 12 has to be greater than or equal to 0 to stay out of those imaginaries, not have a negative under the root. Get that by itself. X is greater than or equal to negative 12. So I can plug numbers negative 12 and bigger into G.